Okay, so let's look at page 54. Page 54. And I think I stopped here on Tuesday, and we talked about symmetry. And now we begin here. We begin from here, and so we talk about more practical things. The requirements in examination. The requirements in examination. These are the 2D problems on page 239 and 240. Now, and for triangles, and for height h, that the centroid is located at h/3. That's for triangles. And you can look at page 239 if you don't have time to copy the figure, or if you don't have time to copy this, and it is on textbook 239. Here, okay? 239. Okay. Now, and then, and for quarter elliptical, and if the length of this side is b, and this y bar is equal to 4b/3π. And for the last one is arc circle. Arc circle, that take your time to copy this first. For these two, and I have you need to remember these three, and for the others that I think you can, I will show you how to do them. An arc circle is like this, and it is like this one. And it has the radius of r, and it goes from angles like this. And the distance x is here. This is the centroid. This is the centroid, and x bar is equal to r sine alpha divided by alpha. I need you to remember these three. And for the other side, I think you can. I will show you how to do that. After drawing the figures, let's think about what's the length of this arc, what's the length of this line. And I'll talk about this in a minute. So after you draw this, and what's the length of this line? Think about this. And of course, this is the equation you need to use, but there are two things you need to remember. The first thing is this angle alpha is in radian. So this alpha is the unit of alpha is in radian. If you put if it is 9 degrees, you put 90 here, you will get the wrong result. Okay. You need to put radians here. I'll show this to you in a minute. And the second thing, what's the length of this line, this arc, or this? What's the length of this line? So length is equal to alpha r, and alpha times r. Remember that the length, the total arc length is, the angle here is 2 alpha, so the arc length is 2 alpha r, and the arc is going from minus alpha to plus alpha. These are the two biggest mistakes your seniors have made in the past years. It's okay. Next, we look at composite plates and wires. And of course, I have told you how to remember these three values, these three equations. I'm sorry, 1, 2, and 3. These three equations, but in reality, many things are more complicated or more complex than these three. So, but we can always make them into simple shapes. For example, this shape is like this, and you can make it into 2 triangles and a rectangle. 2 triangles and a rectangle, and sorry. And so if we want to determine the centroid of this area, then we think we can make use that we can help working on it by cutting it into two triangles and a rectangle. Okay. Now, suppose we do this and make it into three shapes: shape 1, shape 2, and shape 3. And of course, from the equation above and from what you know, we can determine the centroids of these three areas. Now, what we want to determine is this one, the centroid of the total area, X bar, Y bar. We want to determine the centroid of the whole area. On Tuesday, we introduced center of gravity by using moments, right? We use moments to explain what is center of gravity like this. Now we use the same concept. We use the same idea to determine X bar and Y bar. Now we determine the moments about axis Y. We determine the moments about Y-axis, and of course, from the meaning of center of gravity, and the moments about axis Y by this area 1 is X bar 1 W1, and by area 2 is moments by area 2 is X bar 2 W2. And remember, this X bar is this X2 bar is this length. And the moments about Y-axis up from area 3 is X3, X bar 3, W3. So these are the moments caused by different areas. This is from area 1, and then we can do this. We can write down the same thing for the two other areas, right? Like this. We want to determine the center of gravity for the whole area, which is X bar, and the total moments, because due to the whole area about the y-axis is like this. The total weight of the whole area is W1 plus W2 plus W3. So this is the force, and then for the moments it is X bar, which is of course this is unknown. Right, this is unknown. But we know everything. We know all the terms here, and we know what is W1 plus W2 plus W3. So we know both of these. So what can we do? We can write it like this, and so X bar is equal to X1 W1 plus X2 W2 plus X3 W3 divided by W1 plus W2 plus W3. This equation is equation 5.7 on the bottom, at the bottom of page 240. It's okay. We will use this equation. I think next Tuesday or next Thursday. Or if you want to have a quick look this weekend, that it is sample problem 5.1. But I will do it. But I will do an example later. Sorry. Yeah. Now we go to next page, and let's work out an example here. And we are putting things from chapter 5 and chapter 4 together. Now we have a uniform semicircular rod of weights W and radius R is attached to a pin at A and rests against a frictionless surface at B, and determine reactions at A and B. The semicircular is this one. And determine the reactions at A and B. So this is so the problem it tells you that this is a pin support. And it has a weight of W. So as you can imagine that that it wants to go down, but because we have a pin support at A, so it cannot go, the whole thing cannot go down, right? But it will rotate, it wants to rotate against point B. Now, and for this problem, determine the reactions at A and B. Now it is, I think it should be, you should be familiar with this because this is something from chapter 4. Now, and we draw a three-point diagram. Because the reaction at point A is, because point A is a pin support, so we have force AX and force AY. And because point B is frictionless, and we will talk about friction in 1 or 2 weeks' time. So it is, or actually you can say it is smooth. They are the same. You can say they are the same thing. So we have point B. Point B, we only have force and going this way. And the difference from the only thing different from the problems we have looked at before is that this rod has a weight of W. It has a weight of W. So where should we put this force? It should be put at the centroid of the rod. After drawing the free body diagram, think about it. And is it a two-force body or three-force body here? And let me put on the dimensions here. What else? I think this is this point A and point B. So is it a two-force body or is it a three-force body, or it is neither of them? The external forces acting on the rod act on points A, points B, and somewhere here. Therefore, all forces act on 3 points of the body, so it is a three-force body. Therefore, and what do we know about three-force bodies? For three-force bodies, the line of action of this force, line of action of this force, and line of action acting on point A will go to the same point, go through the same point. It's okay. The line of action of force acting on point B, the line of action of the force acting on this point, and the line of action of the force acting on point A will go through the same point. So here we can simplify the problem by saying we know the force at point A will go in this direction, I think. And we can mark this angle with. Of course, you can work it out. You can do it as AX and AY, and then you use the free equations to determine AX, AY, and B. Of course, you can do that. But this is another way to do this. If you want to do it as free equations that in textbook on page 244, sorry, 244, and in the textbook they use free equations and then determine one by one. But I want to use this triangle method to do this. Now the second thing. Now we know that it is a free-force body, and we can simplify the problem like this. And now the second thing is, what is X bar? Where is the centroid of this point? So if we know the location of X of these points, and of course we will know X bar. x bar, and now we need to use the equation I talked about before. Now, and x bar is equal to r sine alpha divided by alpha. Now what is alpha? Remember that our alpha is half of the arc length. Okay, so it goes from alpha and alpha. It goes from minus alpha to plus alpha. For this equation to work, it's okay. For this equation to work, we need to remember that this is minus alpha to plus alpha, and alpha is in radian. Alpha is equal to radian of 9 degrees, which is pi over 2. Therefore, x bar is equal to r sine pi over 2 divided by pi over 2, which is 12 over alpha. It's okay. Oh, right, sorry. Right, yes, thank you. 12 over pi. It's okay. And for this, now we go to, so after everything from this free force body have been solved, now we work on the equilibrium. And the summation F equals to A plus B plus W equals to 0. Therefore, we can draw the triangle here. And this one is and this is right angle. And from here we can, of course, this theta can go here as well. It's up to you. Now, and from here, and from the geometry we know, and W over B is equal to tangent theta. This is from the fourth polygon on the left. From this graph, of course, we know W over B is equal to tangent theta. And from this, and from the free body diagram, we know that tangent theta is equal to, this is what? Equals to 2R over beta. Sorry, 2R over pi. Therefore, it is equal to pi. The right-hand side comes from the free body diagram above. So because this x bar is equal to 0 over pi, so from here, we'll know this one. Of course, I'm going through quickly, so please take a look at home as well. Therefore, B is equal to W over pi to the right. And I think you can do the rest, because A squared plus B squared equals to W squared. So A is equal to W times 1 plus 1 over pi squared, and goes to theta. And theta equals to arctangent of pi. Yep. All right. Oh, yes. Sorry. Okay. Thank you. It's okay. Of course, I'm going through it quickly. So take a look at home and take a look at home and when you do your revision. Now, I think for this problem, it is like those in chapter 4, except we need to know the centroid of this rod. So for the rest, it is like those in chapter 4, right? Now for the before I end the class today, I want to talk about a bit about the next topic. And this is of course I have asked you to remember the centroid of some areas, but in more complex or complicated areas or lines, we need to find the centroid mathematically, and usually we do it by integration. Now, and of course, then we have calculus class for you, and just after this, and but let me go through it quickly and have a brief look at how do we determine the centroid by integration? Now, and if you are not familiar with this topic, and go home and read pages 200 and 250 and 250. Sorry, 250. And I will go downwards from here on next Tuesday. And if you are not familiar with this topic, go and spend your weekend and to read this. Okay. Before we end the class today, and let me mark this figure. And this is a triangle. This is a triangle defined by these three lines. Now, x-axis is here and y-axis is here. And we say point O is here. Now, I have a question. How do you write the equation for this line? Y equals to what? For this line, for the line here. Y equals to, because usually we write this, right? Y equals to mx plus c. So for this line, how should we write this? Y equals to, you can say in Chinese or English. Because it goes through 0.5. So this line is equal to, okay, that is good, and 1/2 of x, okay? And of course, the other line is y equals to minus 1/2 of x. What else what else I can write here? Okay. Let me mark one more thing here. So for integration, I will go it like this. I'll go forward like this, and we will consider one stripe here. We'll consider one stripe here, and the width of the width is equal to dx. And its distance from here is equal to x. Okay, and think about it. How should we go on from here? If you are familiar with integration, and think about how should we go on from here, and we consider one small area here, and then and we consider after we consider the total moment about point O. From Tuesday, I will go here, and then I will go to here. Have you learned this and the integral with these two things on it? Have you learned about this? Yes or no? Yes. So, and these are we call definite integral. But I will repeat this on Tuesday. Okay.